Alright, hello everyone. So welcome to the second video on the ratio test to figure out the convergence of a series. Today we're going to be looking at series B here, which is 1 to infinity e to the n plus 4 divided by the quantity 1 times 3 times 5 2n minus 1. Basically stands for the product of odd numbers starting from 1 up to 2n minus 1. Now let's look at the ratio test. So you're given a series starting from 1 to infinity to an, for which an is not equal to 0 for infinitely many n. Consider L the limit as n goes to infinity of the absolute value of an plus 1 over an. If the limit L is less than 1, then the series converges. If L is greater than 1, then the series diverges. And if L equals 1, then the test is inconclusive about whether an converges or diverges. All right, and this is a good candidate for the ratio test just because of the fact that you have an exponential and you're taking a product. Almost looks like a factorial on the bottom, not quite, but that's a very good candidate for the ratio test. So that's why we're applying it here as well. So let's compute this limit. Let's figure out what an plus 1 is. So an plus 1 would be e to the n plus 5 all over 1 times 3 times 5 times 2 times quantity n plus 1 minus 1. And let me speak about one thing that often people miss out on. The term 2n minus 1 is in here. The reason for that is as follows. If you looked at, let's say you figured out what A4 was, A4 would just be e to the 8th over 1, 3, 5, and then 2 times 4 minus 1 would be 7. And if you found a sub 3, that would be e to the 7th over 1 times 3 times 2 times 3 minus 1, 5. Notice how, and the what I'm saying, this is A4 is like saying an plus 1. Think of it this way, when n equals 3. And A3 is like an. That last value is in here, okay? And often a lot of people forget about that and they get this problem wrong because they don't include that. This is specifically when you're multiplying an odd number of, a product of odd numbers like we have here. So then that's what a sub n is. A sub n plus 1, excuse me. I'm going to divide by a sub n, which would be e to the n plus 4 over 1 plus 3 times 2n minus 1. So again, that's a sub n. And we're going to now divide and simplify this a bit. So dividing, you get e to the n plus 5, 1 times 3 times 2n minus 1. And then 2 times the quantity n plus 1 minus 1 becomes 2n plus 1 times 1 times 3 times 5 2n minus 1 all over e to the n plus 4. And things would cancel out here. The 1, 3, of course. Basically every term up to 2n minus 1 would cancel on the denominator of en plus 5 over 1 times 3 times 2n minus 1 over 2n plus 1. So let me write what we have so far. And then another thing that would cancel is that e to the n on both the e to the n plus 5 and the n plus 4. More specifically, e to the n plus 5 is like saying e to the n times e to the 5. And then e to the n plus 4 is like saying e to the n times e to the 4. The n's cancel, and then you have one e left over 2n plus 1. And of course, you have your limit sign. Don't forget it, because your professor will take a point off. Don't. And this limit will just go to 0. So it's less than 1. And therefore the series e to the n plus 4, 1 times 3 times 5, 2n minus 1 would converge. All right. Very nice. And the reason we like the ratio test here is because when you do the an plus 1 over an computation that you see here, you often will cancel off things with factorials or exponents really nicely, so that's why we like it. The limit comes out to be somewhat fairly easy to compute. Right, well, thank you for your time. Hope this helps.